Section 3.4, Solving Applied Problems in Two Equations. Systems of equations can be useful in solving applied problems. Using systems often makes the translate step easier than using a single equation. The first kind of problem we consider involves quantities of items purchased and total value, or cost of the items. We refer to this type of problem as a total value problem. Example 1. In order to pick up lunch, Kathy collected $181.50 from her coworkers for a total of 21 salads and sandwiches. When she got to the deli, she forgot how many of each were ordered. If salads cost $7.50 and sandwiches cost $9.50, how many of each should she buy? Okay, well, when you're working with these type of problems, you can always make a nice chart where you have item 1, item 2, and your total, the number of your items, the cost, and your total. Or it's often referred in a general sense to your rate. If you fill this out, you see that your salads plus sandwiches will be 21, where D is salads and W is sandwiches. And then we have the total cost that's made up of 750D plus 950W equals 181.50. While the chart is helpful, the way I think about it is I make an equation. I know we're going to have two equations. Our first equation is maybe, like in a general sense, the quantity, how much we're working with. And then you're going to have another equation where you're working with maybe like a cost of something, for example. So if we're thinking of items, we have salads plus sandwiches equals, well, how many sandwich orders do we have? A total of 21. Now we have the one that talks about money. We said that $7.50 is the price of a salad plus $9.50 is the cost of a sandwich, and it equals a total of $181.50. The chart is helpful, but I just like to read it a handful of times and start to categorize our information. Now we're left to solve. So if we solve our system, you can solve it any method you like. Let's begin by getting rid of those decimals. So we see that if we multiply everything by 100, since everything's in the hundredths place, that will get rid of our decimals. We'll move our decimals to the right one. So that we have 750D plus 950W equals 18150. Okay, let's go ahead and solve. So this is our system of equations. D plus W equals 21. 750D plus 950W equals 18150. Alrighty then. So you can solve any method you like. How about substitution? So let's solve. So I have D plus W equals 21. Let's get D by itself. So minus W, D is equal to 21 minus W. Let's plug it into our other equation so that we have 750 times D, which is 21 minus W, plus 950W equals 181.50. All right, let's distribute the 750. So 750 times 21, I have my calculator handy. That gives us 15750. 750 times W minus 750W plus 950W equals 18150. Let's combine like terms. 950 plus 750, that's 200. So we're left with 15,750 plus 200W equals 181.50. Let's get W by itself. So minus 1, 15,750 to both sides. You get 200W and 181.50 minus 15750. You get 2,400. And yeah, I'm using a calculator. Always have your calculator handy. So we have W is equal to 2,400 divided by 200. We get 12. All right, we found W. So we know we're going to order W, which is salads, 12 salads. Let's finish it off. So we have D plus W equals 21. We know W is 12, or we can just plug it into this one. D plus 12 equals 21. To get D, let's subtract 12. D is equal to 9. All right, last bit. Since we have a word problem, we have to give a word answer. So Kathy should order 9 sandwiches. Oh, D is salads. D is salads. And 12 sandwiches. Cool. Next one, we have a mixture problem. Mixture problems are kind of weird. So let's go ahead and do this problem. Spice It Up sells ground turmeric for $1.35 per ounce and ground sumac for $1.85 per ounce. Ethan wants to make 20-ounce seasoning blend of the two spices that sells for $1.65 per ounce. How much of each should he use? Okay, so what's different here is that we're mixing things up. When we're mixing things up, it's not as um, straightforward as our last question. For this one, our chart is helpful. So you do want to make your chart with your item 1, your item 2, and then your total, your sum. And then by your rate and your total. So item 1, let's say item 1 is sumac. Let's write S for sumac. So sumac will be S. And T for turmeric. And we said that the total amount of these 2 ounces of these 2 spices blended would be 20. So we have S plus T equals 20. Now we have to consider the price. The price of turmeric is 185, so we have 185S, like here. Oh, S is for sumac. And turmeric is 135, so 1.35 for T for turmeric. Now here where it gets tricky. That price per ounce is 1.65, $1.65. But we want to make a 20-ounce mixture. So we need to multiply 165 by 20 to get 33. That helps us create our equation. So our system is made up of S plus T is equal to 20 and 1.85S plus 1.35. T equals 33. Let's go ahead and solve. So like before, let's go ahead and get rid of our decimals. Let's multiply everything by 100. And that moves our decimals over twice so that we have 185S plus 135T is equal to 3300. And our equation above, well, that's fine. That one stays the same. Okay, let's go ahead and solve. I'm going to go ahead and use substitution again. So let's solve for s for that first equation. So I have s plus t is equal to 20. If I want to get s by itself, I subtract t. S is equal to 20 minus t. All right, let's plug that into our other equation. So I have 185s. Instead of s, we said s is equal to 20 minus t, plus 135t is equal to 3,300 or 3,300. I have to distribute 185. So 185 times 20 gives us 3,700. So 3,700 minus 185t. Well, that's just 185t. Plus 135t gives us 3,300. Let's combine like terms. So negative 185 plus 135, we get negative 50. 3,700 minus 50t is equal to 3,300. Minus 3,700 minus 3,700. 3,300 minus 3,700, you get negative 400. Lastly, divide by negative 50 to get t by itself. So we're left with 400 divided by 50, we get 8. All right, so we know we're going to get 8 ounces of turmeric. Lastly, we plug it into our equation. 20 minus t, t is 8. We get s is equal to 12. All right, let's answer our question. So Ethan would buy 12 ounces of sumac, s equals 12, and 8 ounces of turmeric, since t is equal to 8. All right, last question for this section. Geron's student loan totaled $16,200. Part was Parkin's loan, made a 5% interest, and the rest was a Stafford loan, made a 4% interest. After a year, Geron's loans accumulated $715 in interest. What is the amount of each loan? Okay, so we're taking a look at the student loans after a year, and we have these two loans are equaling a total of 16,200. We have to consider the percents and their interests. So our two equations, you can always make a chart. So we have one for the loans. We have these two loans, Perkins and Stanford. Their total for their loans is 16,200. Now we have to consider the interest. At a 5% interest, so remember to change your percents to decimals. Quick review. If I have 5%, to make it into a decimal, you move it over to the left twice. So this is now 0.05. So we have a 0.05% for one, which is your Perkins, and 0.04 interest for the other, which is your Stafford. Now we're looking only at the interest. The percent is what creates the interest, and these interests summed up to be 715. Okay, now we have our equations. Just like before, if you want to go ahead and get rid of the decimals, move it over twice to everything. So we're multiplying by 100. So that we have 5x plus 4y is equal to 71500. Okay, So our new equations without the decimals, we have x plus y equals 16,200 and 5x plus 4y is equal to 71,500. And the reason why that second one looks different is, remember, we got rid of the decimals by multiplying by 100. Okay, let's go ahead and solve. I'm going to do elimination this time. Remember, elimination is another option. I want to get rid of that 5. So let's multiply that first equation by a negative 5. All right, if we do that, I have to be very careful because I make so many mistakes. Minus 5x minus 5y is equal to 16200 times 5. We get negative 81,000. All right, my second equation is 5x plus 4y is equal to 71,500. Let's go ahead and add them. While my x's make 0, I'm left with negative y is equal to negative 81,000 plus 71,500. We get negative 9,500. So we divide both by y, we're left with y equals 9,500. All right, let's take a look at y. Y is, well, we found y. Let's go ahead and plug it in. Let's use that first equation. So I have x plus y is equal to 16200, and we're going to let y equal 9,500. Let's plug that in. X plus 9,500 is equal to 16200. You subtract that. X is equal to 16200 minus 9500. We get 6,700. 6700. So now we know how much each loan was. That was our question, right? What is the amount of each loan? So X was Perkins, Y was Stafford. We can say something like the Perkins loans was $6,700, and the Stafford loan is 9,500. And yeah, that's how much student loans look. And that's student loans kind of on the lower end. All right, so that was 3.4, solving applied problems in two equations.